Yay! All right. Start with something very simple. Well, you get the idea. Thanks. I'll disconnect, just to warn you. Okay. Since there's not too many people here, you can maybe get a sense of what the real colors look like here. So this is voice 1. This is voice 2, and this is voice 3. Sorry, it's 3. Yeah. Yeah, let me start now with this. I don't have a company, but I have a logo. So I'm a logo in search of a company. That's my logo. So this is Cornflower. It's a real-time music composition app. It's Listbased, real-time. It's meant for improvisation. I do a fair amount of live coding, so this is partly where it comes from. It was built with using Juice. Both the interface and the sound engine are from Juice, so the whole thing is Juice. And you can see that there are separate fields for pitch dynamics, rhythm, etc. You can enter values numerically or MIDI values. And so the design and technical direction is myself. Programming in this case was done by Kieran Hart. My previous apps I did pretty much all by myself, but this time I got some money from the university to help me to build this one, which was great. And as I was thinking about how to present this, I thought the only way I can really talk about how this came to be is to talk about my own history. And so I came up with this idea of autobiographical software development. It's a new thing. You know, you build software that's about yourself. So I hope this doesn't seem too narcissistic or self-involved, but hopefully this will help explain it. The first time I saw a computer was 1985. It was Commodore 64, and it was connected to a television monitor and doing some really basic music stuff. And I just thought, this is the best thing since sliced bread. You know, I have to get involved with that. And so the same year at my university, they bought an Apple IIe system. It was connected to an Alpha Centauri system, which is now a defunct company that built you could see it says here, Alpha Centauri. So Alpha Centauri connected to an Apple IIe. That was really my first experience working with computer-based music. And then I bought myself an Atari 520 ST in 1987. It had built-in MIDI ports, the only computer I know of ever that has had built-in MIDI ports. It was actually a great, great machine. And sadly, I sold it. In 1980, around the same time, I taught myself how to program in Forth. Anybody here familiar with Forth? Yeah, nobody. Well, one person. All right, all right. I read this book on programming languages. There were 6 chapters, and chapter 6 was Forth, and the author said Forth is a language unto itself, and it is. But the basic unit of Forth is the word, and so it has a basic dictionary of words, and you make programs by using just you build new words out of words. So I really liked that concept of having just these atomic units. And as a person who was interested in the arts and literature, it just kind of made sense for me as a programming language. Dr. T was a guy named Emil Tobinfield, who was one of various very earliest producers of really sequencers, MIDI-based sequencers. And so I had this Dr. T's music software that I had installed on my Atari ST. And it was all list-based. It was just event lists. So just lots of text. So this is just a series of note-ons, and you can see what the note is, and you see how long it lasts, and when it occurs. And so that was my initiation into computer music, is just lots of text and lots of lists. By the way, I'm a classically trained composer. Yeah, I've been playing piano since age 10. I have my PhD in music composition, so I'm like, that's where I come from. And that's how, and then I fell in love with computers. So I have these two worlds colliding. This was really another important influence for me, in addition to the whole idea of lists and data, was working with Janos Sanaka's UPIC system, this is a huge drawing tablet. It's hard to see, but he was really the first person who figured out how to, well, he and his team, he was a composer, how to use drawing to produce sound. And so this was a system they developed in 1976 in Paris. And so in 1998, I went there and I spent a month studying how to use the UPIC system. And by then it was just like a Wacom tablet, it was about this big. And so you draw on it and you could draw all these lines. And so, but I started to get into my head this idea of working with continua. So on the one hand, we have this thing of, atoms and lists. On the other hand, I had this notion of working with continua. And these are two composers from the UPIC studios, Gerard Pape, the director, Julio Estrada, a Mexican composer, but they wrote a book, Gerard wrote a book, I'm kind of a bit fuzzy on this, but they wrote a book called Composing in the Continuum, and that idea has always stuck with me. Then in 1998, I was writing a piece for orchestra. It was actually my dissertation work, piece for orchestra. And I thought, how am I going to do this? How am I going to write this piece for orchestra? This is really quite a task. And I thought, well, I know a bit about programming. I'm just going to write code that's going to create. Basically, I had notions of gestures, but I thought, how do I actually fill in the gestures? How do you get all the notes exactly right? And so I found this software by Paul Berg, which he started around 1990 and worked on it for 25 years. It's Mac only, AC Toolbox, it's List-based. Anybody here program in Lisp? All right, Lisp people. Lisp stands for list programming. So we come to this notion of working with lists. This is a kind of a very Lispy syntax here. It's a DSL, it's a domain-specific language based on Lisp, but this was really when I became serious really about programming. And so I was working with this Lisp system, which is a list-based system. And it's just so elegant and simple, the syntax. You just have a function name, and you have a list of stuff. Either it's a list of functions, a list of arrays, a list of data points, and you give functions to functions to functions to functions. And I just thought, this is the greatest thing since sliced bread. You take a function and you feed it as an argument to a function. That's brilliant. And so that's why I'm saying the person who talked before me, Nick Thompson, he was talking about functional programming. There's a lot of overlap between what he was saying and what I'm interested in. This is just an example of a piece I wrote, and this is how the code is actually working. We don't really need to go through this, But it's maybe what's interesting about it is the actually the first function, which is changing weight, which is about probabilities. So the next slide I show you is going to show you how this probability phase shift is working. So I have a list here, list of numbers, a list of numbers here, and these are basically probability ratios, 5 to 1. That this event is going to be chosen is 5 times more likely than that one event will be chosen. This one is 4 times more likely, 4 to 2. The ratio is 4 to 2 right here. They're equally likely to happen. These are all ratios. You see the lists are of unequal length, so there's a phase shift. So the probabilities are continually looping, but the phase is changing. So you get this complexity that's emerging from a really very simple process. So there's, in the world of music composition, this has a history, this whole notion of phase shift. In the 13th and 14th centuries, I should say 14th and 15th centuries, medieval composers were working with something called the isorhythmic motet. And if you look at this, you'll see there's a pattern of a rhythmic pattern here that gets repeated 7 times. But the pitch pattern is actually 28 notes long, right? So you have a pitch pattern that's 28 notes long, a rhythmic pattern that's 4 notes long, and they just keep working, looping independently. I think that's, what I'm trying to get to is the notion of looping independently. And so they might be out of phase, they might be in phase. Steve Reich, I assume, how many people are familiar with the music of Steve Reich? A few, yeah. Phase shift is his thing. If you don't know the music of Steve Reich, you have to check it out. Music for 18 Musicians, Come Out is his most famous electroacoustic piece. He started working with electronics, and he sort of migrated to working with ensembles. And his ensemble work is just smashing. It's amazing. But he was working at the whole notion of phase shifting. Then in 2007, I met Pauline Oliveras. She became a mentor. I studied with her on and off for about 9 years. She came up with this concept of deep listening. She founded a whole practice around deep listening. So I went to a number of workshops with her. Actually, she became a friend until she died a few years ago. And what I learned from her was how to honor my listening. So if I'm live coding, I'm always listening, I'm focusing on listening. And what do I hear internally and what do I hear externally? Both those worlds. And one day I was talking to her partner, Ione, and I said, I've just got all this, music floating around in my head, and I feel like it's kind of the detritus of all the music I've ever heard in my life. And she said, well, so what? So what? It's, honor it. So I decided then, so what? I'm going to start to really paying attention to that stuff. So what are my sort of abiding concerns? Well, algorithms and code as musical and artistic tools, but also the use of algorithms for personal expression, that I'm not writing something that's an object out there, that's creating some other object out there. It's actually something about me. And there's some process whereby when I'm doing this abstract thing of working with an algorithm, it ends up expressing something about me. This is my theory. It's partly about effortlessness and efficiency. Wu Wei is a Chinese concept. It's actually a Taoist concept about how you can accomplish something with the least effort possible, which I think coders will understand fully. So it goes just hand in glove. This sort of spiritual, philosophic concept just, works beautifully with the practice of writing code. And so I also have an interest in these overlaps between sort of spirituality and coding. And that relates to virtuosity. It's like, who's the virtuoso? The virtuoso is the one who can accomplish the most sort of with the least effort, right? And in music, which is the world I come from, virtuosity is a big deal. People care about it a lot. And then in the past few years, live coding, so tidal cycles. Anybody here know tidal cycles? Okay, it's a wonderful Haskell-based live coding language. It's the tersest, the most efficient music coding language I have ever found, and that's why I use it. I have been looking for a live coding language for a long time that I could fall in love with, and I finally found one. But it's not everything I want it to be. And that's one of the reasons I ended up making Cornflower. so that I could take some of the stuff I had learned from Lisp and Paul Berg's AC Toolbox and somehow integrate it into the live coding practice that I kind of had become accustomed with tidal cycles. Some of the stuff I've done, with these tools. So I used AC Toolbox to produce an ambient electronic album called Music for Being. I used Reactor for the sound. Some of you might know that's a Native Instruments wonderful coding environment. Then I became an iOS developer, and I made an generative audiovisual work called Dancing Wu Wei. I used AC Toolbox for the music, open frameworks for the graphics, generative graphics. That's a C++ library. And I used the processing language for the prototyping for that. And then 2017, I did a similar work called Infinity. Again, used open frameworks. And in this case, I used Enzian Audio heavy tools. Heavy tools used to take pure data patches and ingest them and then spit them out as C code or as a plugin in multiple formats, which is now what Faust does. Basically, what Faust does now is what Heavy was doing like 5-6 years ago. And so I used that for this app. I took some C code and put it into the iOS app. That worked beautifully. This is a slight tangent, but it's a bit more theoretical work I've done, which is code is prosthesis, the notion that writing code is a kind of prosthetic experience, that it becomes a part of you. It kind of becomes an extension of you. And this is actually a website that I built, interactive, using d3.js. I did that with a student of mine. So please check it out. It's called codisprosthesis.net. Okay, so now we're coming to the thing that got this software off the ground, which was I came up with this notion of Spark, specification, audiation, and real-time composition. So I wanted to develop a series of templates for the rapid creation of mobile audio software. And again, this is where my talk overlaps with the previous person's talk, which is that Nick is looking for a more efficient way to build software. Yeah, and that also comes back to my whole point about autobiographical software, that we're not just building massive tools for massive numbers of people to use, but it could be software, it could be something about you, something that just you need. So I wanted to create an app that facilitates real-time composition, including the facility to easily disseminate the output, the recordings. And I wanted to build a beautiful interface. So the visual part of it really mattered a lot to me. And I got funding. I got some funding to do it. I was able to hire a student to do most of the coding for me, so that was great. SWCTN is a Southwest Creative Technology Network. So that's Bristol, Bath, Cornwall, a series of universities working together. So what is audiation? Audiation is actually a term coined by a man named Edward Gordon. He developed a technique of learning music theory. But it's basically what you hear in your head. Audiation is music or sound that you hear in your head that doesn't actually have a physical out there reality. It's just in here, right? And then specification. I think we all know what specification is. So audiation is kind of a known experience, but it actually needs something to get outside. And specification. So when I specify a musical structure, I might have a sense of what it's going to sound like. Maybe I don't. I don't know. It could be completely arbitrary. I might specify something without really having a good sense of what it's going to sound like. So there's kind of varying degrees of knownness or audibility. But in neither case are those things yet material. They're inputs, two different kinds of input that then somehow have to become material. So in order to complete them, we have to build them. And so I think with Cornflower, basically that's what I'm doing. I have this audiation process, listening, specification, making some choices. And then when I hear it, I start to respond to what I'm hearing. And then I hear something new. There's a new process of audiation. There's a new process of specification, and that cycle just continues. So this is the interface that you saw. So we've got these 3 arrays: pitch, dynamics, rhythm. You can either do this with numbers or you can do it with standard music notation. Dynamics is kind of arbitrary, but if you know MIDI notation, which probably most of you do, it's 0 to 127. Rhythm is done in using proportions. And then you just, you press these buttons and it enters. All these numbers start to form lists here. And you cannot edit the list except to step back. Yeah, so the operations are very simple. The editing operations are super simple and basic, and they're very limited. And one of the things I discovered at the outset is that having those limitations was really very fruitful in creative terms. Yeah, having very limited choices kind of forced me to start writing music in a different way. So there's that. You can just enter stuff and clear it. Same down here. You hit the play button, and you can hit the record, but you record everything you want to do. And then when you finish recording, you hit the button again, and you can share it. I'll show you the share screen in a minute. Then you have here the options for voice 1, 2, 3, and there's a BPM slider there. It goes from 48 to 300 or 240 or something like that. I don't remember the top end anymore. So there's voice 2 and there's voice 3. And here's the share page. This actually works quite well. This is built into Juice. Unfortunately, you can't really tweak it much, but it actually does work fairly well. So we've got this list of recordings. You can delete it, you can share it, you can play it back. And then there's a setting page. You can choose whether you want WAV, MP3, or OGG, sample rate, buffer size. This I never even touch. The number of voices, that is fairly significant actually, but again, I don't really change that too often. You can choose whether to use the reverb or not. The top one is actually also fairly significant. Do you actually want these things to be synchronized, these lists to be synchronized or not when you start? Do you want the first event in one field to always be aligned with the first event in the other field? Or do you want to be aligned at the time you play it? And so the sort of compositional effect of that is quite different. If you don't tick it, you get a lot more surprises, and those surprises are really helpful. This is how it looks on a phone. I always use it on my iPad, but it actually works quite well on the iPhone, certainly on the newer ones. On my Android, and this is the reason I haven't released it on Android yet, that's one reason, is that on my Android it lags terribly, the interface, it really lags badly. But I do have an old iPhone. So what's the dynamic? Well, I think you've probably kind of seen it. It's a creation of overlapping and interlocking event lists while listening to and responding to the results. Exploiting the creative potential of the constraints. So I've decided quite early on, I don't want to develop this into a really large number of features and options. I want to sort of rein it in and leave it quite constrained. And also, it gives me some options to make specifications in terms of visual patterns. So I kind of like the grid, sort of going back to what this looks like. When I look at this, I think, well, what will it sound like if I go like this? If I do some kind of geometrical pattern, I don't really know what that's going to sound like, but it should be logical, you know? So that's part of the game. And so, starting then to talk about the programming part of this, one of my objectives at the beginning of this project when I was working with Kieran was, well, let's look at some different ways we can build this thing and see which one seems to work better. And I built a prototype interface with React Native because I teach React Native. When we got into, I used to teach Swift app development, Swift and iOS. But when COVID hit and we had to do everything online, I had to find a dual platform solution. So I went to React Native and I learned React Native. And I really like React Native. It's actually a really nice framework to work with. And Tone.js is just a JavaScript audio library. So we started with that, and then we did a project with that, and then we did a project with AudioKit, and then we actually did a different project with this, and then we went back to this idea, the one that you've seen, and did it with Juice. And so I'll just sort of show you what were the results of that. And these are mostly comments from Kieran, who did the programming. So, you know, building UI with React Native, certainly the easiest of those three. He said Tone.js has the best documentation, but it's difficult for a native app. We find, you know, it wasn't very performant in a native environment. AudioKit, as one of the speakers, I don't know if you heard the person who spoke about Make It earlier, AudioKit is by far the easiest to work with of these three in terms of just conceptual clarity. Recording the audio is simple. Kieran says a two-way binding made it easy to manage state. But of course, it's iOS only. And so for that reason, I thought, no, we're not going to go with this because I really want to, this time, make an app that Android users can use, which is still not there. Juice, lots of functionality, but customizing is difficult. We did have more control of the audio synthesis, and I should say the sound that you heard was a physical modeling instrument, right? It was basically a string model. And we used the same kind of model in AudioKit, but it was not as good. Yeah, the quality of the physical model in AudioKit was not as good as the one that's in Juice to my ears. Although controlling the ADSR is quite difficult with this one. I'm still not totally sure why that is. It's super robust. If I can just go back, I mean, on my iPad, it rarely crashes, even if I really make it work hard. I'm just gonna sort of do something ridiculous here. Yeah. Just choose some random notes and play them as fast as I can. So it's very robust. I'm very impressed. But it is the most complicated. You know, it's C++, and C++ is just not fun. 5 minutes, all right, I'm getting close to the end. Yeah, I don't like, I've had to program in a C++ and I just don't like it. Sorry. UI is difficult to work with. As I noted, on Android, it lags terribly. A lot of questions get answered in the Juice forum. At the same time, I have to say, the Juice forum is not always the friendliest place to be. It's sometimes a bit prickly there, and I've been in other environments where it's a bit friendlier. But yeah, he said he did get his questions answered there. So what are my frameworks of interest? Well, I'm very keen on functional programming. I've been studying Clojure for the past year. I've been learning Elm and Clojure quite a lot in the past year. Recently learned about ReasonML, which is another functional language. Faust, I've spent a bit of time with. So what I really want is some kind of unification of declarative UI and real-time audio synthesis in one package, and I think that's actually sort of what Nick Thompson was talking about in the previous talk. JavaScript to me is maybe not the ideal. Syntactically, I don't find it the ideal choice. But this is what Nick said, writing audio DSP is too hard. And it prevents smart people from making audio software. And I agree. Features for future releases. I want some stochastic functions. Some graphic options. I like to do some drawing. And I'd like Bluetooth transmission. And things that I rejected, like doing non-tempered pitch, arbitrary rhythmic units, a variety of timbres, plugins. These are other people's ideas that were suggested to me, and I just thought, well, no, that's what you want. It's not what I want. It's not what I need for myself. And I know I'm not trying to make a universal tool. I'm just trying to build something for my own use. That's it. Thanks.
Thanks, Ron. Does anyone have any questions?
I counted
60 blocks.
Yes.
So you're considering 5 octaves.
5 octaves, yeah.
Sorry, Gus.
Because it's just, it's in my experience, what's really proved to be musically useful most of the
For
time.
the people online.
Oh, yeah, yeah.
So sorry.
Yeah, yeah.
I'll just repeat for the remote audience.
yeah.
I've asked if you can bring back the image. It's going to make more clearer. So I've asked about the notes. As I was counting, you're starting from 24 until 84. So simple math, I got it. 5 octaves all in all.
5 octaves, yeah.
Okay.
Yeah, just because those are the ones that I have found to be the most useful musically, and I had to limit it, you know.
And can any of those do a drum machine? Could I be reading a sample library that I have predefined?
No.
No? No. It's all synthesized.
It's real-time synthesis, and there's one sound. And that's another one of those constraints that people said, yeah, how about multiple sounds? How about choice of sounds? And I just thought, maybe someday, but I'm, you know, for my purposes, being very selfish about it, this is working for me.
Do you have an audible example of doing multiple voices? I think, and I'm not sure.
The demo had all 3 voices.
3 voices.
At the beginning, that was 3 voices, yeah.
Okay,
yeah.
Thank you.
Yeah.
So I have one question.
Just going back to the physical modeling side of it, I just wondered what model it was that you used and how you kind of realized it.
Oh, well, it's the Juice standard string, physical model of a string instrument, which is usually a Karplus-Strong algorithm, you know, which I'll admit I'm not an expert on the Karplus-Strong algorithm, but it's kind of the model that most people start with, at least. Yeah.
It might be interesting to, once you have a pattern going, to do simple transformations of each list. I was wondering whether you considered anything like a rotation or
yeah. Well, the first thing I thought of, and probably the first thing I'll implement is just pure randomization. You know, that's such a simple shuffle. You know, and I do that all the time in my composition. You know, really simple random arrangements. But another thing would be what I would also like to do is to just have a subfield where you enter a series of notes, you assign it to a symbol. And then you can use the symbol in the main list. And so then you're sequencing subsequences, which is what Dr. Tease did, you know, back in 1987. He was very clever, yeah.
I have a question about Android. We all know that the audio system is terrible. Have you heard any news about the improvements they might be making?
Yeah, it's getting better. Yeah, definitely. Originally the lag times were just totally unacceptable, but it's improved quite a lot based on what I've read. I'm sure it depends on which brand you have. And you can go online and see ratings of different brands, and then, you know, none of them really approaches iOS yet. Some of them are getting close. So it's improving.
Since it's Juice, I mean, have you thought about making a desktop application?
No. I mean, I've thought about it because people have suggested it. But actually, because I'm a mobile developer and I'm still kind of stuck in this, I really like this, you know, that I can just run around and touch it wherever I am. And if I'm doing a desktop, I'm either sitting or standing. I've somehow become static.
And it works offline?
Yeah. Yeah, I can be walking through the street and doing this with headphones and make a recording and go home and upload it. And that's fantastic. Yeah.
Thanks. It's great to see someone really scratching their own itch so successfully. It's something that, you know, to be able to have the opportunity, it's great to see that.
Thank you. Thanks very much.
So something that I think certainly will try it myself. It's on the App Store, right?
It is. Yeah.
And how do we find it?
He's got it. Yeah, just type in Cornflower.
Cornflower, great.
Yeah.
Of course.
Yeah, and let me know how you find it.
Oh, thank you so much, Ron.
Thank you.
Really fantastic.
Cheers.
Thanks.